The universe is not silent. It's just that human ears are so tiny, too limited, to hear the giant symphony that's rocking out there. I look up at the night sky and thought the universe was absolutely silent. But that feeling is just an illusion created by the senses. If an astronaut goes into space, he won't hear the explosion, not listening to the wind, not hearing any familiar sounds. It's not because the universe is dead, but because of the sound. People know, need intermediate material to transmit vibrations from one place to another. On Earth. LAN Audio Air Hitchhiker, where the molecules, VAs constantly touching and bringing energy to our hands, in water or metal. The sound moves faster, by the particles of matter there, denser and more tightly bound. But beyond the space between the planets, ultra-low material density, that these vibrations are almost no longer transmitted. So in the foot, not just the familiar sounds of Earth's life. It simply can't exist the way we hear it. And that's what led many people to conclude that the universe, absolute silence, a cold space that's silent and nothing echoes. But the truth is that the universe has never been really quiet. It's just speaking in languages human ears can't understand. Throughout space, there are countless vibrations of radio light, Tia X, Tia Gamma, plasma motion, and magnetic field variations. They're not sounds in the familiar sense, but they're all rhythmic signals, structure and information from the universe. When scientists convert those signals into frequencies, man hears the universe begin as if to speak. It's not a fabrication to make a compelling video. It's about how people translate physical data into experiences. I can feel it. Neutron stars spinning madly, the distant pulsar. Sent to us, it's pulsating like a space clock. When converted to sound, the sounds are like a cold ticking sound. Scary regularity in the endless darkness. That's what people lack. It's not a universe that vibrates. It's that the body is fit enough to hear it directly. Humans only evolved to survive on Earth. Between the air, the wind, and the footsteps of this world. I want to hear the universe. We have to borrow the ears of the telescopic machine, radio sensors and devices that are more sensitive than the senses. And as these machines open up new hearing to humanity, we realize that the universe has never been silent for a second. When machines instead of humans listen, the universe is no longer a silent picture. It's like a sea of data vibrating. The radio telescopes. They don't sound like human ears, but to pick up the signals that are actually passing through space. Every radio signal from space, it's a kind of wave that carries information and rhythms, waiting to be deciphered into what people feel. Scientists don't make up space sounds. They just convert the invisible vibrations into solutions. Frequency people can hear. It's called sonification, where data is translated to audio, to the ears. We're touching phenomena that are outside of biology. One of the first voices in the universe that humanity heard coming from the dead Punsa keep the characteristics of exploding stars. Punsa is a fast-spinning neutron SAO, emits a beam of radiation like a lighthouse spinning in the dark. Every time that beam of radiation crosses the Earth, the telescope recorded a steady pulsing of incoming signals. Cold people. When converted to Punsa sound, it sounds like a mechanical ticking. It's so precise that it's like a space clock. There's Punsa spinning hundreds of times per second. Cause the pulse to rush. It's like a machine trying to break through the night. But it's not just dead stars that give off signals. Right in the solar system, the giant planets are also whispering with radio waves. Jupiter is particularly noisy on the radio spectrum. When from its giant field accelerates charged particles and agitates. Plasma, if you listen to transcripts of Jupiter's data. It feels like we're standing in front of an electrical storm. There is no rain. The sun is not silent, and inside it there's plasma, creating LAN oscillations across the giant fireball. Scientists read these vibrations as the study of SAO to hear the structure hidden deep inside the sun. Even interplanetary plasma can vibrate. It makes strange squeaks when recorded by the probe. Voyager picked up those vibrations at the edge of the solar system, where the VA solar wind enters the inter-SAO environment. Every place in the universe doesn't make the same sound. Each source has its own voice as an instrument. Pulsar beats like a clock. Jupiter roars like an electric storm. And interstellar plasma rises like metal fibers. It's stretching, and that's just the tip of the cosmic music. Before we get to the deeper depths, But there's a place in the universe where sound isn't just frequency conversion data. It starts with a real pressure wave. That's the Perseus cluster. A giant mass of thousands of galaxies submerged in a sea of hot gas glowed violently with X-rays. It's different from a vacuum. It's almost empty between the planets. Environment. Hot air here is material enough to oscillate land transmission. So in the heart of Perseus, the ripples produced by black holes can behave like sound. In the physical sense, at the center of Perseus is a supermassive black hole hidden in the galaxy Perseus. It's constantly pumping energy into the environment. When matter falls near a black hole, it doesn't fall silent. That unleashes enormous energy through the jet and the outbreak. These flares push the heat away to stop inflating giant voids in the environment. Intergalactic, surrounding the instrument, as these empty cavities expand, they send out pressure ripples like land waves on the water. After a strong VA touch, the Chandra telescope, see those same pressure ripples in X-rays. It's like these loops of fading waves passing through the sea of air. From the distance between the ripples and the speed of sound in the instrument, the scientists deduced an amazing altitude. If you change it to a note, that oscillation corresponds to a subtle note, so low that the human ear is completely helpless. It's about 57 octaves lower than the one near the midburn. It's deeper than any natural sound humans have ever heard. The frequency is too low, to the extent that a cycle of oscillation lasts for millions of years, turning the entire galaxy cluster into a very slow speaker. In other words, it's not a roar like the movies. It's a bass that spans the cosmic time scale. The strange thing is, this subwoofer that can help keep the gas in the cluster. It's always hot. It cools and crumbles. A black hole, therefore, doesn't just swallow matter. It's also stirring up the environment around it by pulses large enough to shape the cluster. Telugu and Chandra turns that data into audible sound, people for the first time, like the voice of the Black Lake. What we're listening to is not a live recording. It's an honest translation of physical structures, out of reach. Listen, and the translation table sounds like a deep, cold moan, that the silence of space suddenly becomes suspicious. By Perseus, humanity understands a terrible Cosmonauts thing. Can sing with deep notes, longer than civilization. We often say that black holes swallow everything, but what makes the universe around it more terrifying? It's how it makes the environment vibrate. A black hole is not a speaker that explodes in a vacuum. It is dark itself. Hold still and don't let even the light escape. But around the edge of that darkness, matter is heated to the extreme. Spin like crazy into an accretion disk before disappearing forever. In the accretion disk, when hot, intense friction, emitting light, X-rays, and the fluctuations that the telescope recorded. In many supermassive black holes, the magnetic field also breaks matter into jets. It's thousands of light years away. These jets don't go through the space, not like pointless arrows. They VA into the surrounding gas, stirring the plasma and creating structure. So when people hear the sound of black holes, I don't listen to the body of a black hole that hears the physical consequences it causes. That's the sound of the hot gas of X-ray plasma, radio waves, and of the VA touching violently near the mouth of the gravitational chasm. A famous example is the M87, the first supermassive black hole photographed by mankind. It's in the middle of a giant galaxy far away from us. What the telescope sees is not the black hole itself. It's a ring of hot, glowing matter. It's bent around the edge by gravity. When Chandra, Hubble, ALMA, and other stations stitch together data, the area around M87 appears to be a machine spraying matter. The data is then converted to sound. Let your eyes and ears enter a human place, never touched. In the sonification of M87, scanning data running around the image like a variable brightness radar, position and wavelength into altitude. Radio is assigned to the optical base zone in Chinese, and X-rays shot up as cold as shards of bright metal. So the sound we're hearing is not a real roar out in space. It's a sensory map of the data. But the map itself, it helps us to sense the turbulence around the black hole, where order and destruction coexist. With Sagittarius A's, or the black hole at the center of the galaxy, infrared and ray data, X has also been translated into sound, where brightness determines volume, and the position of the source determines the altitude that makes the center of the galaxy a vibrating field. Listen to those translations. We realize that black holes are not just devouring darkness. It's the invisible conductor of violence. And as the story goes on, we'll go further, to a time when the early universe was sounding like a CA. Before there was SAO, there were galaxies. The young universe is not dark and quiet. It's a sea of hot, pulsating plasma. In the sea of plasma protons, electrons and light are bound together. It causes matter and radiation to behave like a liquid. Everywhere, gravity tries to pull matter together, but the pressure of the hot light pushes back out. The fact that there are waves of compression and expansion land through the early universe as sound runs through the air. In other words, the childhood universe actually used to sing, even though the CA is beyond any experience. The human hearing, each oscillation starts from small differences, could come from the early quantum, then LAN-RA when the plasma transmits vibration. It's like throwing a pebble into a lake. Each concentrated area emits a distant LAN carrying energy through the sea of fire. But this is not ear-to-ear sound. It's a pressure wave running in the dense, hot environment of the young universe. If there's a hearing that's wide enough and durable enough, it's going to hear the universe as a galactic field. The notes don't ring in seconds or minutes that follow these giant time scales, where a long oscillation. As the universe continues to expand and cool, the tension between gravity and pressure is changing, but the wave trail is there. 380,000 years after the Big Bang, electrons and protons combine light to be free for the first time. It's like the orchestra is frozen in the middle of a performance, and the sound ripples are imprinted in the background. That background light is the cosmic microwave background radiation, the oldest photograph ever taken by man. Very small hot and cold spots on the background radiation. Not random. They're memories of vibrations from the infant universe. After billions of years, the ripples still leave the preferred distance. In how galaxies converge back into a network. Today, the houses. Astronomers read that trace like audio fossils. They're called barium-negative oscillations. They don't show us the original CA intact, but it says that the early universe had a structured rhythm. From that fossil song, humans measure the expansion of the universe, times, according to the history of matter and darkness. And the most amazing thing is that it's before the stars, before even the life of the universe ever sang. After understanding the universe knows vibrations, bigger questions arise. How people actually start to hear it. The answer doesn't start with the ears, but from machines that pick up weaker signals. Every biological sense. Radio telescopes don't sound like talented people, but they're picking up radio waves emanating from distant objects. Every radio signal is an electromagnetic oscillator that carries and information about the object that created it. When the signal is amplified, noise filtering and matching conversion, man can hear the beat of the sky. That's why so much cosmic sound. It's not actually recorded directly. It's an honest translation of the physical data. Thanks to that translation, things that were once invisible become close. It's as if the universe spoke for the first time. A punsa that can sound like a cold clock, and a moon can turn into a long sound. Even a still astronomical image, it can also be converted to sound when the brightness and position become high. And many research groups have turned space data into sonification. It opens up a way of discovery that's both scientific and emotional. But listening to the universe isn't just translating light or radio. Sometimes space-time itself vibrates strongly enough to be caught. When extremely heavy objects accelerate violently, they make space-time ripple. It's what Einstein predicted. Leo. Joe first recorded gravitational waves directly from two merging black holes. It opens up a new sense of astronomy. That signal sounds like a very short flash. Quick spike and off. But behind it is the VA collision that distorts space-time. For the first time, humans didn't just see the universe with light, but also listening to an event using the very fabric of space. And then in 2017, gravitational waves from two SAO touched VA neutrons detected along with light across multiple wavelengths. This event proves humanity has entered the era of multi-messenger astronomy, where a phenomenon is heard and seen at the same time. Meanwhile, Voyager 1 also recorded plasma oscillations in interstellar space, where the dilute environment still has strange vibrations. These signals don't look like familiar music, but they prove that the darkness between them. I have never been completely silent. From radio plasma to gravitational waves, humans have built artificial ears to hear the hidden part of the universe. If the human ear extends far enough, the universe will no longer be a silent sky that turns into an ocean of sound that doesn't sleep. The first thing we realize is that our ears are too narrow, just hearing a tiny slice of reality vibrating. People usually hear about 20,000 hex, while the universe stretches far beyond that limit. If every new prize becomes visible to the auditory, we'll live in endless layers of overlapping sounds. The space between them will no longer be empty. It's like a giant room full of plasma breathing. Pulsar will ring like cold clocks, beat accurately against the bank's deep night background. The pulses spin faster and faster. It sounds like the machine is grinding its teeth into itself. Darkness. The wood will not appear as a silent sphere. It's like a giant electric storm under the magnetosphere. The sun won't just shine. It's like a living reactor. Boils and trembles in each plasma layer. Even the still astronomical pictures. It will also become noisy because the brightness and position can both be negative. Then your hands will touch something stranger than sound. The cry of space-time, when VA heavy objects touch. A black hole merger won't explode like the movies, that pops up with a sharp, eerie flash, and hit the neutron SAO differently, like a metal scream that lasts longer. Brighter and springing out in the rain of light. The plasma oscillations that Voyager touched at the edge of the interstellar will sound like a metal wire stretched in the cold darkness. In Composius, the black hole's base won't be the explosion. It's a groan so deep that time slows down. If you really hear it all, the night sky will no longer help people relax. It's going to be an alarm. I will listen to the dead, planets roaring plasma-rich streams. And so no time is softly relaxing around us. And then, the silence that mankind has believed for thousands of years will unfold. It's just a shortcoming. Space biology never stops talking. It's just that people are so new, too fragile to immediately understand its language. But now, with mathematical machines and curiosity, humans have begun to learn to listen to the darkness.